So now we're going to look at some problems where some of these triangles start attaching or combining with others. So in this one it says calculate the length of xy to the nearest tenth of a centimeter. So we're looking for xy, this length here. So obviously in this right angle triangle, we know the angle and that's it. But to find xy, we're going to need to know some other part of this triangle. Okay, so that turns us to this right angle triangle here. We have the angle and we have a side, which means we can use this triangle to calculate either WY or WZ. Obviously, WZ is not going to help us with the goal, so we should solve for WY. Okay, so I'm going to pull that triangle out and we're just going to work with this. This is going to be our unknown, YW. Okay. This was 8.4 and this is 20 degrees. So I'm going to name this side here, how about I'll name it P. And so I'm not going to repeat any of the letters that are used. Okay. So let's name what we have. We have the angle, we need the opposite, and we have the hypotenuse. So we're looking at the sine. So we're looking at the sine of 20 degrees is going to be equal to P divided by 8.4. To solve for P, we need to move this 8.4, so we need to multiply both sides by 8.4. Okay. Once we do that, these cancel out. So P is just 8.4 times the sine of 20. So I'm going to put that in, 8.4 times the sine of 20 degrees, and that gives me 2.87, and I'm going to round that to 3. But usually we're going to keep ourselves with 3 or 4 decimal places just so that our final answer is correct. So we have this distance here for P. Okay. Now let's pull out that other triangle. So we now know this is 2.873. And this angle here is 22 degrees. And the goal is to find this side here, which maybe we'll call Q. Okay. So let's name what we have. So we have the angle, we have the hypotenuse is what we need to find, and the adjacent was what we just solved for in the last problem. So we're looking at cosine of that 22 degrees is the adjacent divided by the hypotenuse, but now the Q's in the denominator. So to move the Q into the numerator, I'm going to multiply both sides by Q, okay, which leaves me with Q times the cosine of 22 degrees is equal to 2.873. And to find Q, I'm going to have to divide both sides by the cosine of 22 degrees. Okay. So these will cancel. So Q is going to be that 2.873 divided by the cosine of 22 degrees. Okay. When I plug that in, it gives me 3.098, but it says to the nearest tenth, so I'm going to go 3.1, and the units are centimeters. So you'll see that these problems tend to force us to do two calculations. Okay. So here we have a word problem. So this says, a surveyor stands right here at a window on the 9th floor of an office tower. He uses a clinometer to measure the angle of elevation, which is 31 degrees, and the angle of depression, which is 42 degrees, to the top and the base of this taller building. The surveyor sketches his plan and his measurements. Determine the height of the taller building. So the goal is to find this completely. Okay. So here we have 39, which means this distance here is 39. But to find the whole height, we're also going to need to add whatever this height here is. But again, I only have 31 in that unknown side, which means I'm going to need some other piece of information. But in this triangle, I have 42 degrees and I have a side. So we could either find for this horizontal or this hypotenuse. Obviously, the hypotenuse is not going to help us, but this horizontal would give us information in the second triangle. So let's name this, I'm going to call it Y. This is going to be what we're looking for in our first calculation. So we know 39 is going to be our opposite, and y is our adjacent. So opposite and adjacent, that is tangent of 42 degrees, okay, which is the opposite side, 39, divided by our adjacent, which we're calling y. So to find our y value, we need to first of all bring it into the numerator, multiply both sides by y. Okay, which just leaves us with y times the tangent of 42 degrees is 39. But we need to isolate for y, so I'll divide both sides by 42 degrees. Tan of 42 degrees, which I'll cancel those out to give us y. So I'm going to take 39 and I'll divide it by the tangent of 42 degrees. So that's giving me 43.31. 43 point. I'm going to give myself a couple more decimal places just to be absolutely sure. So I'll put 39. Okay, so we have y now. So I'm going to pull out that second triangle just to show what we're working with. We need to find this side. We now know this is 43.3139, and this is 31 degrees. Okay? So we have the x is the opposite side, and 43 is the tangent. Sorry, not the tangent, it is the adjacent, which leads us to understanding opposite and adjacent is TOA, so it leads us to knowing its tangent. So we're going to be taking the tangent of 31 degrees is the opposite divided by the adjacent. Okay, this time x is in the numerator, so we're going to have to multiply both sides by that 43.3139. Okay. These cancel out. So really in my calculator, I'm just taking 43.3139 and I'm going to multiply it by the tan of 31 degrees, which is going to leave me with 26.025. So I'll just put 26.03. Okay. So that's this height here. But remember, the goal is to find the total height. So the total height is going to be 39 from this triangle added to this new 26.03. Ooh, plus 39, sorry, 39. So if I add those up, I'm going to end up with 65, and it says to the nearest tenth of a meter, so it's actually 65.0. The units are in meters. Last but not least, we have this third problem here. So this is a typical problem that we might see on the provincial exam. So this says a communication tower is 35 meters tall. From a point due north of the tower, Tanis measures the angle of elevation of 70 degrees. Her brother Leaf, who is due east of the tower, measures an angle elevation of 50 degrees. How far apart are the students to the nearest meter? So we're looking for this length here. Obviously, to find x, we're going to need to know some sort of information about this triangle. So we're really going to have to know this side length here and this side length here. And then we could do the Pythagorean theorem to find z. So really, we're going to one triangle, two triangle calculations to complete. Okay, so let's look at this first triangle with Tanis on the corners. So we have 70 degrees. We're going to call this y, and the height is 35. So let's name what we have. We have the opposite, and we're looking for the adjacent. So that's tan, TOA. So the tan of 70 degrees is the opposite divided by the adjacent. So I'm going to multiply both sides by y to get y into the numerator. Okay. And then to isolate y, I'm going to divide both sides by tan of 70 degrees. Okay. Which means y is just 35 divided by the tan of 70. Okay? If you plug that in, you're going to end up with 12.739. So we have this length here. Okay? Triangle number 2 is the one with leaf, which has an angle of elevation of 50 degrees. We're calling this Z, and again, this is 35. So the opposite is 35, the adjacent is Z. So again, we're looking at tangent, but this time at 50 degrees is 35 divided by Z. So if we follow along this way, what's going to end up happening is we're going to multiply both sides by Z, but then divide both sides by tan of 50. So really, this is going to become 35 divided by tan of 50 degrees. Okay. If I plug in 35 divided by tan of 50 degrees, I get 29.3684. So now we have this triangle. So this is the triangle right on the base here. I'm just going to pull it up. Okay. And this is here the y value we said was 12.739. And this value was 29.368. And we're really looking for this value here, which I named x. Instead of doing trig here, we have two side lengths and we're looking for the hypotenuse, so the best bet would be to do Pythagorean theorem. So let's do 12.739 squared plus 29.368 squared is going to be equal to that x squared. So I'm going to calculate each of those values squared, and I'm going to add them together. So I'm adding that 29.368 squared, and I'll add that 12.739 squared, which is going to give me 0,702 equals x squared. Okay. Now I'm going to do the square root of both sides to get approximately 32.01, but it does say to the nearest meter, so I'm just going to write 32 meters. That's how far Tanis and Leaf are.